Hi friends, how are you? So today we are going to start with numericals as I have told in the last lecture that this the second part of the numerical series will also be of the numericals. So let's start with the numericals. Okay. So uh, we are working currently on the numericals equals numerical I equals to V by R. Okay. So in this series, like they can be like reversed or something like that. They can be reversed and all that. Please forget for me for the camera setting. It can be up and down. Okay. So my face will be visible sometimes and not. Although focus on the board, nothing is in my face. Okay. So, sixth question because five questions we have done in the last lecture, and now we are going to start with the sixth question. So, as you know, I am having my book written every question in it, and let's start. So, the question is a car headlight bulb, a car headlight bulb working on a 12-volt battery. So, what is the battery? It is 12 volt. From this we know the potential, electric potential or potential difference is 12 volt. Okay, so let it write simply potential. Okay, potential. Then what is the current flowing? This is the second question. Or current or let tell us resistance. Any of them. Okay. So current flowing, they have tell the current flowing. So current is 0.5 ampere. Okay, 0.5 ampere. Find the resistance. Very easy peasy question. Okay, so find the resistance. So a super triangle, let's zoom in some. This is a special triangle which tells us that V, I, R. This triangle is suggesting us now that as you want to find resistance, it will be equals to V by R. And we know what is V. Okay, so R equals to, now let's write V. So we know that V is 12 volts and I is 0.5 amperes. Yeah, so it is equal to 12 so 120 divided by 5. So it is of course 24 ohm. As uh, this is the 24 ohm, we it is easy to calculate this way or otherwise you can do this way. Okay, so you can write 120 volt by 5. The same answer will come 24 or not. Okay, 24 ohms. Okay, so this was an easy peasy question. So let's go with the second one. Okay, like question number 7 for us. Yeah, so an electrical appliance has a resistance of 25 ohm. So here resistance is given first. So let it note it down. It has a resistance of 25 ohm. One electrical appliance is connected to 230 volt supply line. Now the voltage is 230 because it is connected, not voltage, electric potential. Electric potential. Okay, so understand it's electric potential when I write electric. Okay, so it is 230 volts. What do you think? What will be the question? It is obvious. They are finding, like they are asking what will be the current. It was an obvious one. So I equals to what by what? Yeah, our triangle is here helping us. V, I, R. So here comes V, here comes R. Yeah, so R equals to what is V here? It's 230 volts. And the resistance is 25. So simply firstly divided by 5. So it comes 5 5s are 46. Okay. So now 46 by 5 ampere you can directly write it Or the other way is just do simply like divide it. So it the answer comes as 9.2 ampere. Okay, so this was the seventh question of today. Today they are mostly easy questions because we have done hard questions in the past video, like the part 14 of the electricity. You must watch that video before it, otherwise you will be having some difficulties. And the explanation video in which I have given you how to solve this numericals, what is the meaning, okay? So you have to solve that also. That's important. Okay, so let's start with question number 8. When a 4 ohm resistor is connected across the terminals of a 12-volt battery, find the number of coulombs. Find the number of coulombs. Coulombs is charge. Flowing pass through per second. Per 2 seconds. Okay. So, firstly, this is a little tricky one but not very easy. Okay. So, what is the resistance given? Resistance given is 4 ohm. If you have forgotten, this is omega sign, which is a symbol for denoting ohms. Okay. So resistors, uh, yeah. So electric current is no voltage is given, not voltage. The electric potential. Okay, so I will write this electric potential is what 12 volts. Find the coulombs passing per 2 seconds. Okay, so first we will find electricity and by the another formula I will tell you. So electric current or tangle. This is important. Like you, if after 1 or 2 years you will remember this triangle and not the formula, it will be easy for you to make the formula. Okay, so V I R. So from this we get I equals to V by R. Yeah. So R equals to V, which is 12, and R equals to 4 ohm. Okay, so 4 ohm. So 4 ones are 4, 3. This is 3 amperes. So this is the electric current. Okay, so I equals to 3 ampere. This I equals to 3 ampere can also be written as you know, I equals to 3 coulombs per second. And it is asked for 2 seconds. Okay, so how much coulomb charge will flow through, in 2 seconds? So obviously multiply it by 2. So 6 coulombs. 6 coulomb charge will flow through the wire in 2 seconds. Okay, in 2 seconds, 6 coulomb charge will flow. Easy peasy. I know it will be. Okay, now we are having question 9. Yeah. A potential difference of 10 volts is needed to make a current of 0.02 ampere flowing through a wire. What is the potential difference needed to make a current of 250 milliampere flow through the same wire? Yeah. So let me check. Oh yeah, it's correct. Potential difference of 10 volts. So V1, because there are two cases here. We have done such questions in the previous videos. Please check that. V1 equals to 10 volts is needed to make a current of, and current is very low. So I1 is 0.02 ampere. So 10 volt is needed to move just 0.02 ampere. Then the resistance will be very great, okay? And flow through. So firstly, let's find the resistance for this case. You're not knowing case, please see the past video first, okay? So by remembering simply we can tell R equals to V by I. Okay, so I will write it down. 10 divided by 0.02, which is equals to 500. So in the R1, the resistance when the electric current electric current is 0.02 ampere and the potential difference is 10 volts. So the electric resistance comes as 500 ohms. I firstly told you that the resistance will be very high. Okay, then for the case 2, the next part of the question, what potential difference is needed? Now, the same wire is there, so the resistance will remain same. So R1 equals to 500 ohm. Potential difference is unknown, and electric current is given to us, which is 250 milliamperes. Milliamperes. Okay, so firstly, let's convert this milliamperes into amperes. So it will be 0.25 amperes. Okay, so let's find, by remembering the formula, we can simply tell that, or let's draw the triangle for your convenience. Okay, I know the formula. It's V equals to I into R for this question. I into, so V equals to I into R. So V equals to I. What is I? 0.25 amperes. So 0.25 into 500. Okay. So for this one, the answer comes as 125 volts. Okay. So the answer is 125 volts, like the electric current needed. No, no, not the electric current. The potential difference needed. In the second case is 125 volts. Yeah, the potential difference. Yeah, this was a easy one. The students who have solved the past ones, like the past video, they will feel it very very easy. Yeah, but the new ones will have some confusions and all about that. Okay, now the question number 10. I'm going fast with this video because we have done all sort of this in the past one, and like we are having a understanding about it, and just for practice we are doing this. Okay, but it's important. Practice means makes a man perfect. Yeah. So the question number 10 is, a current of 200 milliampere flows through 4 kilo ohm resistor. What is the potential difference across the resistor? Okay, so the current is given. So yeah, I equals to 200 milliampere equals to 0.2 ampere. Now flows through a resistor of 4 kilowatt resistance. Okay, so resistance is very high. 4 kilo ohm, not kilowatt, kilo ohm equals to 4000 ohm. It's a high value, yeah. And find V. The numbers are large and small. The difference is very big, but the formula is same. Yeah. For your convenience, I will draw the triangle. Otherwise, I know the formula for which is current into resistance. Yeah. So V equals to I by R, which is equals to 4000 into 0.2. Okay, so 4000 into 0.2 results in 800. So 800 volts is the answer for this question. Okay, so 800 volts is the electric potential difference if a current of 200 milliampere is flowing through a resistor of 4 kilowatt. Okay, so 800 volt electric potential is needed, or you can say potential difference is needed. Yeah, I'm having one extra question for you. You have waited till this, so a bonus one. Question number 11. The potential difference across a register is 3 millivolts. It was kilovolts. No, no. This is potential difference. In the before question, it was the like it was a very big resistance of 4 kilo ohms. Okay, so the potential difference is 3 millivolts. Like milliamperes and milliohms, it is 3 millivolts, which is equals to 0.0.03, no, not 30, 0.003 volts. So the electric potential. If a current of 200 ampere, so there's a very big gap. If a current of 200 ampere is flown, then find the resistance. Resistance equals to V by R. No, no, V by I. So V is 0.03 volts, 0.003 volts, and it's 200 amperes. Yeah. So this is the question. Now to simplify it and make it better, let's make it in like natural numbers. So it will be 3. No, messed up. 3 and now 200 and 3 zeros. 1, 0, 3. Yeah. So this gives 3 ones are. It is not divisible, but yeah. So here one more method is given for doing that. We can like write 1 minute. Here I have I faced this problem while solving numerical also this numerical. So I made a better option like better method for it. I will show you that only. First I done with this method and at the next time I saw and done with the better one. So okay, so current is 200 amperes and voltage is what 0.003 volts. Oh wait, yeah, 0.003 by 200, which can be written as 3 by 2. This equals to, instead of this, we can write like no no this one. Yeah. So 3 into 10 to the power minus 3 by 3 into 10 to the power minus 3 by, let me cut out this zero, by 200. We can do it by this method also. Yeah. So now we will divide this 3 ones are 3 six are. So 6 are and then 2 remains, 66.6 recurring. Okay, the answer will be equals to 10 raised to minus 3. So 10 raised to minus 3 by 66.6. Yeah. So this simplifying it more will be harder and not necessary also. We can directly write it as 10 raised to minus 3 and the answer will be there. Okay. Yeah. So you know what is 10 raised to minus 3? It is like 0.001 by 66.6. Okay, let's simplify it as we can more. Okay. So 0.01 by 666, which results in 1. I will further extend it to 1 by 66600. Yeah, it will stop here now. And finally, here the answer will be, I have written it down somewhere by solving this, simplifying this. So finally, the answer will be 0.000015 ohm. Okay, so 1, 2, 3, 4. 1, 2, 3, 4, and yeah. So final answer of this question will be this. 1 minute, I will write it properly. Yeah, this is the final answer for this question. Okay, so today's numerical part was interesting and quite easy peasy. Okay, so because we have done this in the past videos, you would have a better practice of it. So that I have made this video. Okay, so study well and like, share, subscribe to our channel, please. Okay, thank you. Bye bye.